welcome to a quick video going over some of the data that I've organized and compiled into spreadsheets. Um, you'll notice at the bottom that there are 5 scatter plots besides the normal data, and that's because I think it's easiest to think about different things when you separate them out. So if we go to the first data sheet, this is just dry press. So this is tofu that was being pressed by different amounts of, let me just double check this, dry press. Yeah, so I've organized this data based on the weight as to which was pressed in terms of those beakers. And then here you can see the final mass and the percent change, and then the final cook time or the final mass change as a result of this. When you're looking at surface area ratios, the bigger the better, meaning that this right here has a very large surface area to volume, while on the other hand, this has a very small to surface area. When we look at our graphs, this is percent change as a function of surface area to volume. So this would be a greater change going down because it's negative, and this would be a larger surface area to volume. When we look at percent change as a function of press weight, this would be more negative in terms of weight loss, and this would be more in terms of the press weight. And then this would be percent change in final mass as a function of surface area to volume. So the final mass that we lost in total as a function of the surface area to volume. Wet immersion is going to be organized basically as a graph looking at the liquid, and then finally the amount of solute that you added. If we look at this, this is a percent change in mass as a function of immersion volume. So this would be more immersion, and then this would be weight gained or weight lost. Notice that I made the water and soy sauce different colors and not part of the overall figure. So this trend line, I believe, is for rice wine vinegar. This would be the final change in mass as a function of surface area to volume. So again, this is looking at percent change, and this is looking at surface area to volume. And that is about all I think you need out of this. The last two are a bit more complicated. So this is going to be looking at solutes and dry press. So this is where you coated your tofu in some sort of salt or sugar, and then you also pressed it. So on the left side is going to be salt. So we have mass and solute strength impacting percent change. So the X column is going to be what your final change was, and then the red data point would be how much salt you used, and then the blue dot would be how much sugar, or not sugar, how much weight you put in the press. The mass press is on the X or the y-axis on the left side. The amount of salt that you used is on the right side. Over here is going to be the percent change in salt as a function of surface area to volume. So I just plotted the percent change in weight as a function of your surface area to volume for these first 4 tofu. Same thing over here, percent change in mass. So this would be the biggest change negatively, mass for press, and sugar amount. And then finally, change in sugar as a function of surface area to volume. Again, bigger surface area, going down, more negative change. To be honest, some of this data doesn't make sense. So that is where you can talk about likely reasons for why it didn't work. It's not just error. There are other things that might have happened as a result of this. And also, you can think about what the data should have been based on your understanding of the data and the experimental setup. Last one is immersion and press. So this is going to be mass of sugar and volume of rice wine vinegar in terms of change. This would be on the x-axis. In blue would be the rice wine vinegar volume, and the red line is going to be the amount of sugar used. And again, this is percent change. Very little change, lots of change. This is going to be the same idea, but thinking about mass and soy sauce. So this would be Red would be the volume of soy sauce used, and we can see that on this axis. And blue would be the amount of salt used and the percent change. And then this would be mass of solute and volume of water. So this would just be looking at the last couple ones that were water in terms of percent change, mass of the sugar or salt used, and then volume of the water immersed in. The other ones that I've made are our distribution of our tofu. So this would be the volume of the tofu and the surface area, thinking about size and ratio volumes. This would be our mass and ratio, so how well distributed was our mass and surface area volumes. And then finally, this would be the percent total change as a function of the initial mass. So this would be looking at how big you were initially and then how much you've changed throughout the experiment. Now, I think these graphs all don't need to be used for your data. I also don't know if you always need to use graphs because you have in each of these spreadsheets organized data with different treatments with beginning and final masses and percent changes. So you can also cite specific values that back up some observation that you were making. I do think you should use some graphs, either talking about data that you see that makes a connection that's understandable, or talking about data that creates a pattern that is unexplainable or error prone. I will say that tomorrow in class, I'm really wanting to focus in on cell messaging, but I will allow you guys to submit this for Friday with the caveat that you come into class and for the first 20 minutes you can ask me questions about the data. And then we'll move on to cell messaging. I'll post that in Schoology, so if you don't watch this video, which you should, you get that message as well. I hope this has been helpful. Please let me know if you have any questions, and have a great rest of your day.